Good morning, everybody. This is Mike Culver. I'm a web services evangelist with Amazon Web Services. And today I'm delighted to be hosting a webinar that is going to involve three separate organizations presenting. I'm going to start with just a brief overview. I'll try and spend less than 5 minutes talking, because really the stars of the show are Gigabases and then MyWalk Airways. And I think that you'll learn quite a bit, and probably most importantly, you'll have real-world perspectives into how folks are using not only Amazon Web Services, but cloud computing and some of the new capabilities that are out there in the technology world. So as I start, I'd just like to sort of set the stage for what this is all about. For those of you who aren't familiar already with Amazon Web Services, really what this first slide is all about is to make certain that everybody understands that Amazon Web Services is not part of Amazon.com per se. Same umbrella, but not exactly the same company. I don't think I need to tell anyone much about Amazon.com. There's 88 million customers out there. I think most folks are well aware of it. That number two, that picture of a distribution center, is really meant to represent Amazon's seller services business, which in and of itself is over a $1 billion per year revenue stream for the company. And there's really two parts to the seller services. On one hand, we run some high-scale websites for other organizations that want to have someone who's a proven expert in the area run those websites for them. And then the second part of that line of business are companies that sell through the Amazon platform. So for example, if you were to go to Amazon.com and search for stainless steel locking hex nuts in the industrial fitting section, you'd find them on Amazon.com, but they'd probably be fulfilled by one of these third-party merchants that sells through the platform. Amazon Web Services is a new line of business, relatively new line of business for Amazon, the parent company. And we've been around 3 to maybe 4 years, depends how you count. We have a number of web services available. I'll talk about those in a moment. But what I really want to make clear are 2 points. First of all, the business that we've built is really designed to be a separate line of business from Amazon.com itself. And by that I mean that we are not borrowing excess capacity of some sort from Amazon.com that Amazon.com will take back when it's time to time for a busy season here, like for example Christmas. This is dedicated hardware. It's dedicated software running these services. It's built using what we learned building Amazon.com, so you get the best practices that you would expect from Amazon. And you'll see a bit about those in a moment. But it is a separate business. So one other thing I'd like to cover off before we move on is what the characteristics of cloud computing are. And I'm not going to try to define cloud computing. I'd really like to just talk about the characteristics, at least as they apply to Amazon Web Services. So first and foremost, XML Web Services define cloud computing. And XML Web Services mean that it's a request-response protocol using XML documents back and forth. When we talk about servers, of course, servers aren't an XML Web Service. In that particular case, an XML Web Service controls the servers. They're on demand in the sense that organizations or individuals are able to go to aws.amazon.com and self-provision these services. In other words, you sign up, put in a credit card number, and have instant access to what appears to be an infinite pool of resources. Well, of course, there's no such thing as infinite at the end of the day. What I'm saying, though, is that the pool of resources is so large that even if you need thousands of servers, you can pretty much count on them always being there when you need them. Equally important is the fact that because there's no sign-up fees or minimum monthly charges or anything like that, there's this notion of unbounded capacity as well. In other words, you can go either all the way up as high as you need, or you can go down to 0. And if you need to go to 0, which is a perfectly valid place to go, then the bill stops and it goes to 0 as well. Which leads me to what the light bulb represents, is this utility billing model. In other words, what I'm saying is you pay for what you use when you use it, and when you turn it off, the bill stops. Amazon has quite a variety of web services. I think that the two that are really germane to what we're talking about today are the first, the Amazon Simple Storage Service, and especially the second, Amazon Elastic Compute Cloud. So Simple Storage Service is a secure and robust and very high-performance object storage in the cloud. Put data in, and it's stored safely in the cloud, in quotes, which really means in a very robust system in Amazon data centers. Elastic Compute Cloud, or Amazon EC2 for short, are on-demand virtual servers. They can be fired up for 1 hour or steady state forever, or when you don't need anything at all, you just turn them off. And once again, it's this utility billing model. The per hour price for the servers is as low as 10 cents. In fact, the most popular server is 10 cents an hour. And I'm not going to talk about the rest of these in the interest of time, but you can learn more about each of these at aws.amazon.com if you'd like to learn more. So with that, I'd like to hand it over to Nati Shalom, who's CTO with Gigabases. And he is going to explain a little bit about Gigabases and then pass the baton from there. So thanks, everybody, and welcome. Thank you for attending.
Thanks, Mike. My name is Nati Shalom, the CTO of Gigabases. With me is also Shai Sitin, who is the CTO, Deputy CTO, who is working with me and will walk through the details of the Miwok integration. Throughout the presentation, I'll try to kind of explain what is Gigabases and also what are we doing with Amazon specifically, and also kind of go through the details of why you would consider or when you would consider using Gigabases on the Amazon platform. A few words about the Gigabases as a company. Obviously, we're not a new company. We're already there around 8 years. We have a lot of customer in production. Primarily, we've been focusing on distributed computing, and that's been pretty much our background. So we've been dealing with a lot of problems that is related to how you spread a lot of business logic across multiple machines, how you maintain the data integrity and reliability and all those type of issues. Our focus was really to enable application to utilize a cluster of machine as if it was one big machine. And we developed a middleware that includes messaging and data and the rest of the things that basically provide a single point of access to enable those applications to utilize those machines. Among our customers are mostly ones from the financial industry, telco industry. I think that's been the major verticals. A lot of them are enterprise customers. So our challenge, and obviously the move to cloud, was actually a very interesting move for us, a very native move for us. One is because we already have the technology. And for us, the main challenge was to bring a lot of those ideas to a more mainstream application rather than the high-end one that I used in the financial industry and telcos. And Amazon EC2 and integration with that actually provide us a very good opportunity to expand and extend a lot of the things that we've done to the more mainstream type of application. And I think Miwok is a good example for that. As you could see here, we've been pretty active on the cloud space for a while. We already got several awards of that. One of them is to be one of the top 50 cloud providers. And we've been pretty active around the cloud itself. Just to give you an idea where we fit into in the stack, as you could see on the diagram here, we've been focusing mostly on 2 layers. One of them is the integration layer with the cloud itself, which basically deals with how you take an enterprise application and orchestrate it. By orchestrating, I mean taking a load balancer, a web container, business logic, and a database, and grouping them together and deploying them in a certain order that will fit the application architecture. And the other part is our flagship product called Gigabases App, Extreme Application Platform, which deals with middleware virtualization. Middleware virtualization basically provides the core services for messaging, data, parallel processing, and grid under SLA. And it does that, again, in a way that will enable you to think as if it was one big server that you're talking to. So the application running on top of that is not really aware of the fact that it's actually running on the cloud, and that's how we're able to provide one of the core value of this platform, which is to take an existing JEE or .NET or C++ application and run them on the Amazon cloud without necessarily rewriting the application or without re-architecting the application. So the actual, right now we're at the point where we have our beta version, I'll talk about that later on, already available. Among the features that you will get out of this platform is the automated application deployment that I mentioned, and also support for different profiles that will enable you to avoid creation of virtual machines that can be pretty complex in some cases. We're also supporting some interesting stuff like auto-scaling and self-filling. Auto-scaling really means that you could scale on demand. I'll talk more about that. And self-filling means that if there is a failure, we'll be able to move the failed piece of the application into an alternate machine or scale down the application to the available machine. The other interesting thing is that it's really provided without installation using a web interface, so you could really experience the full production-ready environment in a fraction of minutes without installing or downloading anything. So that's kind of a brief view of the, I would say, the architecture layer and where we fit into the stack. Obviously, we're utilizing the Amazon to provide the CPU and the core services of the cloud itself, the actual infrastructure, the CPU, the network, and the storage. I'll talk more about it later on. The flagship product, which is the Gigabases ZAP, is really the middleware stack. As I mentioned earlier, it is responsible to providing the core services, i.e. messaging, read services, and data to different set of applications, and we include a variety of them in different languages. So the basic idea is that if you're running on any of those platform or languages, you'll be able to utilize the scalability those framework provides, and again, utilize the resources that are available on the cloud. If we go quickly about the features here, it really also enables you to decouple a lot of the details of running in the cloud from the application that is running there. The reason why you would use that platform, I think that one of the clear cases that people are moving to cloud is things that is called peak load behavior. You can see here a few scenarios. Unfortunately, the first one is not viewed well, but in general, peak load is something that basically happens in almost every domain of application, whether it's e-commerce and whether it is a financial application. And essentially what we're seeing is a trend in which the peak, the delta between the peak load, whether it's seasonal peak like Christmas in e-commerce sites or trading a perfect storm in the financial industries, is growing over time and therefore becoming an issue. The way to deal with this type of challenges is basically by over-provisioning the systems, and usually that involves static provisioning. So that really means that on a static environment, we'll provision for the peak load, as you can see here, the quote from Intuit, which really means that we end up with a lot of resources being provisioned and by average not really being utilized. So that's kind of the way or the place in which we are today. The solution is pretty straightforward. The ideal world, we want to do just the right sizing, but what is the right sizing? How do we determine the right size when we're facing fluctuating load? How do we deal with it when we have, at the peak, 100 machines, at an average 4 machines? Will we provision 200 machines for that? Amazon EC2 is actually a great mean to address this right sizing, because one of the core things that you will need to address right sizing is to be able to get resources on demand. And if you don't have an available pool, then obviously you're not going to be able to deal with that. All that is great. I mean, ideally, we do and we can leverage the EC2 and the Amazon Cloud really provides us the ability to really get to the point where we can create resources on demand rather than waiting on the line for buying them and connecting them to our infrastructure, etc. However, there is a challenge. There is a missing link here that we're trying to address. If we look at the normal enterprise application, this is pretty much how it would look like. If we'll try to add a machine to this type of environment, most likely that nothing will happen, because there is all this interlink between the web servers, the application, the database. All those things are pretty much static in many ways, and that's kind of the typical tier-based architecture. So if we'll add another machine, and the fact that we can add more machine on demand, we're not really going to have any effect of that application. So we really need to be at a point where we could actually add those resources and that the application would expand and shrink based on the load automatically. And in that case, we'll be able to really exploit the value of cloud computing. We'll need to be able that if one of those pieces dies, we'll be able to, again, move that piece to another machine without the user really noticing any of that event. So that's really where Gigaspaces fit in. And the typical idea that we're using to address those type of challenges is virtualizing the entire application stack. So as you can see here, the principle is pretty simple. We're basically running on something that is called processing unit. Unfortunately, because of the time, I'm not going to be able to dive into the details of that. But essentially, that means that we're removing a lot of those moving parts and putting them into a single box, the messaging and the data that was previously running on different box. We have one cluster for the entire application. And therefore, all the web front end can look at the entire units as if it was one big server. They're not really connected directly to any of those individual servers. From an EC2 perspective, we're basically utilizing different services of EC2 to implement that model. Obviously, the machine and the CPU using the EC2 service. We're using S3 as the application repository that enable us to take the application code and provision that on demand on the machines once the application is being deployed. DevPay is a very good service that enables us to simplify all the billing services using the Amazon images. So we basically attach the product into an image, and that's pretty much it. Amazon also comes with handy tools like the EC2 and the S3 and the Firefox plugins that makes the work with EC2 much simpler. The other interesting case study for us is that we're using the EC2 and the AWS services for really reducing a lot of the complexity for buying and for using Gigaspaces. Essentially, what that really means is that you could experience a full production environment without even downloading Gigaspaces. Imagine what that would mean for the evaluation cycle, for the testing cycle, for the sales cycle, and it's actually enabled us, Gigaspaces, to reduce a lot of that barrier and reduce a lot of the cost of sales involved with that. The service itself is available already on the Amazon EC2 on the gigaspaces.com/mycloud, and you can see a snippet of that. And obviously, we'll see a real-life example of MeWalk application running on this platform today. We have several customers already using them. We have a telco company that is using it. We have in this case, they moved from a software as a service, from a standalone application to a software as a service. We have another global telco provider who is actually using that to do two things. One of them is remove a lot of the compute application, which requires a lot of resources into the cloud, and still to manage the security issues, connected back to its on-premise services, which maintain the critical data. So all the calculation is done on the cloud, but still the data remains in the local facility. Other global media company and financial startups and online gaming company, all of them are using the cloud for various use cases. I'm not going to get into the details of that. I really want to get to the MeWalk example. I think that in itself is a very good example on how you build application on that. So with no further delay, I'll pass the mic to Jim or to Gad.
Hello, this is Jim Harriet here. Let me just get the next slide up here. Okay, next slide. Am I on the slides now? Okay, there we are. Thank you very much. So I am Jim Harriet, and I'm with Fly Me Walk, a very new, not just an air service, but a new really genre way of getting around. So what we represent is essentially a next generation form of transportation, which I'll get into, and also a next generation form of application, which I think is the kind of killer app that's going to dominate the next decade. So we are very pleased to be here with Gigabases and Amazon, and here to show you what we've done with the Gigabases and Amazon, our EC2 platforms, to actually do an application, run a business, as I say, next generation type of business. We are a whole team of people you see here, in particular Gad, Veit, and the lower two are me, Jim Harriott, and Bruce Sawhill. We are the CTO and chief scientists here at Miwok, and as you might guess, this is, although it's a very air-intensive, obviously we're flying airplanes, it's also a high-tech application, next-generation high-tech application. In a sense, we spent the last few years figuring out how to move bits around the network. Now we're figuring out how to move atoms around similar type of networks, and that's a lot harder. That's really why we need this kind of technology, because it's so difficult. So the big idea of Fly Miwok is that people are now ready for, have wanted for a long time, and now we can deliver personal air transportation. You fly when you want, where you want, on demand. You don't have to wait for somebody else to tell you what the schedule is. Take it or leave it. You make up your own schedules as they were. It's on demand. You only buy a seat, not the whole plane. You don't buy a fractional plane. You buy a seat. You choose whom you fly with. You fly with anyone you want, or you can fly with friends, alone. It's your choice. We can deliver this kind of service with technology nowadays for essentially economy airline prices, hundreds of dollars for a seat. And we deliver real-time reservations. I'd like to fly now. I'd like to fly in a couple of hours. Your reservation's confirmed. It's that kind of a turnaround that we are delivering using this technology. So what about this? Well, why? It's this is a market which essentially allows you to get around the car. We essentially compete with the car. This is a very lucrative travel market for us. As you say in the slide there, 84% of all U.S. business travel is short haul. 80% is less than 250 miles, and it's a big business. So even if we get a small fraction of a big business, it's big. So the big news is, with that in mind, we're up. We actually have our Fly Miwok reservation system, at least version 0.1, meaning it's just beginning to hum and run. It's not live yet for customers, but nevertheless, it's on Gigabases. It's on Amazon EC2. It works. We will demo it today. We're very pleased to be doing things this way. We have a reservation portal up, which you will see. All of this is running on an EC2 right now. And we have a certain amount of middleware, businessware going on behind the scenes to do pricing and finally actually to compute, soon to be able to compute the actual itineraries for our aircraft. So it's a lot of computation. It's a lot of very fancy web front end. And it's a lot of state, which we keep in Gigabases, and a kind of architecture that we need a lot of scalability. So now that it starts getting down to the sort of technical side of things, now that hopefully you understand what our business is, essentially moving atoms around in the form of people from seats on aircraft. But why is this so hard? Why isn't it just like any other application? Well, it's hard because Fly Miwok is an on-demand air service. There are no schedules. Everything is dynamic. So we have to respond to customer requests in seconds, but there's no schedule. So we have to figure out not only is there an aircraft, but is there an aircraft that can go to the right place at the right time where you want it to go and still have room in the system left over for things, disruptions, weather changes, and so on. So we have to respond very quickly to customers wanting something essentially novel. It's hard because of the dynamic scaling. Obviously, demand for aircraft and use are constantly fluctuating, but it's even harder than that because disruptions can avalanche. If we have a very large weather system going on, a lot of things can be affected very quickly. And since we have to basically take customer reservations and map those to aircraft itineraries so the pilots know where to go next, all of that has to happen in seconds, even if we have a huge load happening. So we're in a situation where the variance of our usage is even greater than it would be for an ordinary system that just has customers coming and going, more customers on holidays and so on. It's even harder than that. We also have a high-growth business model. We plan for expansion to new geographical areas very quickly. Customers expect a very high level of service, so we have to be able to respond very quickly and grow quickly. So what's the solution? We looked at a lot of possibilities, including Luke Skywalker's lightsaber system, and our judgment was that we wanted to put our system, which I'll explain in a sec, on Gigabases and EC2. That seemed to be the best solution. Our system is essentially a Web 2.0 front end, which writes into Gigabases. It's a flight optimization system that reads and writes from Gigabases. Namely, that's the smarts, the genetic algorithms of the high-level mathematics, which understands how to take all of these aircraft and utilize them most efficiently. And then the operators, the people, the pilots and so on, they get their itineraries also via the web. So the whole system is via the web, and the whole system lives on the back end, zero capital costs for us, and all of it is centered around Gigabases. The solution is a scalable system, and we have to be scalable. It has to be distributed data storage. We wanted Java-based modern software. We wanted a single corpus of software, all Java, all modern, all ease of use for us to get going. And we wanted a demand-based, low-capital IT system. We don't want to spend a lot of money on IT. We did that before. Both Bruce and I, CTO and chief scientist, came from Dayjet, which had a much sort of last generation IT system, very capital intensive. We wanted to do it better this time. So we wanted to use cloud computing, and Amazon AWS EC2 was the right way to go. The smarts behind the system, so there's the web system, as I mentioned, and the Gigabases, but the smarts that figures out exactly how to map our customers, our requests, to utilizing the aircraft most efficiently is very fancy mathematics that uses genetic algorithms and so on. It's fairly compute intensive, and it also likes to have the kind of resources that we can get on an EC2. So as you can see on the upper yellow diagram, each of those verticals are a potential aircraft. All of the colored segments are flights starting from the bottom to the top. And in worst case, there would be 83 reservations in this case, which would be 83 aircraft. Going down to the lower diagram there, that's 10 aircraft, and the flights, the colored boxes, have been organized. They've been packed together in a way that's extremely efficient. There's the yellow turn time in between, 30 minutes at each airport, but there are no deadheads, there are no ferrying, there's no relocations in this case. We were able to, in just a few seconds, go from very large numbers of reservations to all packed together, and then finally on the right hand we fly the schedule. So that's the kind of computation that we do, and which makes possible this kind of a air service, and all of this running, as I say, on Gigabases and EC2. So all of that taken together, we get an architecture that looks like this, which we'll be demonstrating. It is essentially multiple instances of web servers, which you see there on the left side in the blues. They all talk to the queen bee of the system, which is Gigabases data store. And on the right-hand side, our flight optimizer, that's the genetic algorithms, the fancy mathematics that does all the computation that maps the reservations to the aircraft itineraries. Multiple instances of everything, actually, of course, multiple instances, even of the Gigabases computation that can run on many virtual machines, as you know. So all of this is an architecture which is very simple on the one hand and very scalable on another. So the web users on the left get serviced quickly because there's multiple instances of their Web 2.0 backend. There is the Gigabases keeping the thing persistent, and there's the computation which makes the whole thing work. So once again, a very simple architecture. We can do the whole thing with zero IT capital costs, and we can scale and get this thing operational very quickly. So with that, let me move over to GAD, and GAD will actually demonstrate this, which we have working right now. Are we on?
Hi. I think there's a technical problem with Gad being on the call. He's actually controlling the interface here. So if it's possible for you to actually speak to the demo as he goes through it, that would be great.
Well, okay, what you see here is the Fly Me Walk portal. So if you're a customer and you'd really like to get from one place to another, let's say you want to go from San Diego to Palm Springs, or you want to go from Burbank to Ventura, wherever you want to go, once again, the idea is you decide where you go, you decide when you go. You just tell us right here, and we tell you if we can satisfy your request. So you're looking at the portal running right now. It's actually running on an EC2, and all of the ability to choose one-way run trip and so on. There he is. Now Gad is now logging in. He's typing in his password, and that functionality on the back end is happening on an EC2 as you watch. This is live. He's going to type in probably where he wants to go. Yeah, he wants to go from SMO, Santa Monica, MYF, which is an airport very near San Diego Airport. It's in San Diego. And he's now looking at, he sees that he can look at where Santa Monica is. He can look at the locations of things. So he has a lot of functionality he can do to look at his past, his present. He can do pricing. He can look at his existing itineraries, future itineraries. So all of this computation is done directly on the EC2. And the state, from one time to the next, all of that information, the state of where I've been, where I'm going, reservations, all of this information, which would normally be kept in a classical bottlenecked database, is kept on Gigaspaces, or our own space. Gigaspaces like space. And that means that we are multiple times of logging in. We can log in, and it will have remembered everything we did. And it can also be, all of the reservations can be computed into itineraries.
Yeah, this is Shah. I would like to add a few words here about what we see here, the Gigaspaces Cloud Console, if I may.
Yes, go ahead and do that.
We see here that the whole deployment actually being done through a very simple interface, which is provided from the gigaspaces.com/mycloud site. It's basically the deployment service, which is available for users, and through a very simple configuration file, which specify the components and the application components which you like to specify. You see over there the Kiori XML. Basically, this is being used to deploy the application. From this very simple interface, you can actually see the virtual machine that has been started. We've got right now 3 virtual machines which are actually running the application. One of them is, in fact, a load balancer, which is running again also on the cloud, which allows you to load balance the HTTP request to multiple web application running on the cloud. All this is started automatically and also dynamically scaled once there are a huge amount of kind of requests coming in. Another thing that can be done over here is to add additional machines manually. You've got over there the Add Machines button, which can allow you to start machines whenever you want. It's kind of a manual scaling. We've got also for the kind of the new users few demo applications which users can start, and we've got a very nice quick tour that allows you, whoever is not familiar with the system, to go through these simple applications and learn how to deploy your application on the cloud. Anything else you guys want to add over here, Gad, or someone else from the Miwok team?
Well, just that this came up so quickly. We were really surprised at ourselves. We think we're high-tech people that have now entered this the world of atoms, and we thought it would take a while even for us, and it was much quicker than we thought. And in particular, the idea of being able to have the system automatically expand on its own, because we like the idea of being able to say, well, we need 3 processors today and 5 tomorrow, but sometimes the peak load, we're sure, will come in so fast that we won't have time to manually intervene. So we're very pleased that there's an automatic way where it can look at, say, oh, we're running 80% capacity or whatever we specify, time to add more processing power. So that's the kind of thing that we like, and it's working. It seems to work very nicely.
Jim, how much time took you to, once you had the application running locally, what was the effort involved to deploy it on the cloud?
Well, I think it took us a day or something, and it's really quick. Essentially, you can get the whole thing running on your machine using local hosts and so on, and then it's just a deployment thing. So, of course, if we had to do it again, instead of taking a day, it'd probably take us half an hour. I mean, it's so fast because it's essentially the same. It's the same process. It's the same stuff. So it's really easy. It's almost embarrassingly easy because you're used to having big IT departments, and we expect the things to take years, and they actually take days and weeks. It's kind of amazing.
Cool. I would like to add over here that we're basically using Gigabases as a container both for the web content, the data, and the business logic. So there's no need to start additional kind of app servers on the cloud. Gigabases is kind of the universal app server, which allows you guys to deploy all application kind of components into a single container. It's a single type of container, which is essentially the Gigabases container. And that's basically. Yeah, go ahead.
No, it's in some ways it's even better than that, because we can actually put a single Gigabases container together with the Gigabases API store. We can store our data there. We can do the web application. We can do the high cycle computation that we need for our genetic algorithms to make this thing go. We can put that all in a single container. And what's really neat about Gigabases is these containers, each with its own Gigabases functionality, can discover each other through this Genie. So there's self-discovery, and so all the other containers discover each other, know about each other, and all of that's coordinated. So we can actually bring it up as a single container, single application, and then it becomes multiple ones, and we don't even have to think about coordinating or even where the other ones are. The Gigabases does this thing called self-discovery. So it's a very that's really the sort of key to why it's seamless to go from a single instance on our machine, on our test machine, to 100 instances or 1,000 on an EC2. It's that self-discovery and all that work that the Gigabases does behind the scenes that in some sense we don't want to know about, but we do like it that it just seems to work, namely that they discover each other and coordinate, and it's logically one single data store.
Jim, it seems that you've got pretty fancy web interface. Can you discuss a bit the different web technologies that you're using and which are being deployed into the Gigabases container?
Well, we use the standard Java J2EE stuff. We use Spring for, I guess, a number of things, including authentication. We use the iSpaces stuff. We have, behind the scenes, there's Ajax is going on, so you have very, very fast screen updates. So we use a number of things. We use Eclipse for development. All of this open source software. So essentially, we were doing everything on open source software, very high quality open source software. And the only thing that we're actually paying for is the EC2, which of course is utility. It can be as little as 10 cents an hour, and then of course we pay for Gigaspaces, which is also quite reasonably priced. So it's really, we're running essentially an entire IT system, which at the last generation would have taken something on the order of probably dozens of people to run it, dozens of IT people, not to mention millions of dollars in hardware. We're running the whole thing essentially for a few cents an hour, and using open source software. So we can go into detail about what that is later, but it's all out there. Apache, Tomcat, all these things are just there, ready to use.
Okay, cool.
Maybe we should answer some questions from the from our viewers.
So this is Mike. Yeah, this is Mike again from Amazon. And I agree, if folks would like to submit questions via the chat window, we'd more than welcome them. And in the meantime, I think it makes sense, Nati, why don't you take it again, and you can do some wrap-up comments as we wait for some questions to arrive and go from there.
Yeah, sure, Mike. I think that the first question is more about the added value of Gigaspaces up on top of EC2. What does it really add? I would add to that question, I mean, you can basically get to the point where you could get an application on EC2 in other ways without Gigaspaces and deploy it. Why and what type of values do you get by running the application on EC2? As I mentioned in previous slides, there are a few things. I mean, taking an application and statically deploying it like in any hosting service wouldn't really require much of the Gigaspaces integration. Gigaspaces support really comes when we really need to leverage the elasticity of the cloud. Obviously, if you're running statically, you can run statically anywhere, and that's not really our sweet spot. If you really want to leverage the elasticity, this is where the Gigaspaces value comes handy. Basically, what we're doing is in several folds. We're addressing the scaling of the front end using integration with the load balancer, which means that we discover new web servers as they are added and add them to the load balancer to enable self-scaling or auto-scaling. Another thing that we're doing is we're doing it in tight integration with the data itself in order that the session state or the state of the application wouldn't be lost. So there is an affinity between the way the load balancer loads the data and the actual web servers, even if the web server changes its physical location. So if it's moving from one IP to another, we'll still be able to route the same session data to that appropriate instance and not to another instance. Another challenge, which is also dealing with how do you maintain the availability of the session, that's really on the front end. We're able to back the session data into memory resources running on the cloud. So even if the web server goes down, the session itself is not goes down, and it's still kept highly available. Basically, it is being copied to another memory. So when the new server comes back, it can still fetch it, even though the actual process died or the actual machine died. On the more middle end, we provide services like grid services that was mentioned in the Miwok to do the pricing, and Miwok was doing it also for forking the actual task to find the route. So to do that type of operation, this type of parallel search or parallel calculations for the pricing, we provide kind of a grid API. The grid API, again, enables you to simplify how you do those type of things. You write your code as if you're writing it to a single server, and we have the implementation, the underlying implementation that takes that call and parallels it across the machines running on those servers, and therefore you get the gain of the CPU speed of each available nodes. And we'll be able also to add or remove those nodes as needed. So we're really operating not on the system level, but on the application level, and add a lot of the ability to the application that will be able to exploit the elasticity and the fact that we can grow and shrink on demand and therefore get the value of elasticity, which is the ability to get resources when we need to, use them when we need to, and pay only for what we use. Without that, you can't really get that as an advantage, especially not in a transaction application. The other part of it is, and I'll finish that answer on that, is that most enterprise applications are really written in Java or J2E or even .NET, and they are written usually in some way of standard. So if you really try to take that application, you'll find that you'll need to rewrite a lot of that. So we're able to take those existing code and basically abstract a lot of the underlying complexity within the implementation and not expose that to the code itself, which makes the exact scenario that Jim was mentioned, the ability to move from a local standalone machine to a complete elastic environment fairly seamless, because most of the logic, most of that knowledge is abstracted from the actual code itself. There is another question. Sorry, go ahead.
Yeah, no, I was going to say, I think you were just picking it up. I believe we have a question about database architecture on this application.
Yeah, right. So the database is one of the common, I would say, challenges when you're trying to deploy an application, a stateful application on the cloud, and there's been a lot of discussion on that specifically. Amazon recently provided a new service which is called EBS, and basically it provides you a fast storage to enable you to store data of the database into the storage system. Unlike S3, it's designed to be much faster and much more designed to be more durable from a sense of the way the database can pick it up using standard interfaces, mount interfaces. What we're doing is two things. One, we automate the process of instantiating a database. So we can take an abstract definition using XML and basically instantiate a machine, install the database on that machine, link it and mount it to a certain EBS, all that without any manual operation. And the second thing is that we're able to scale the database by fronting the database with a lot of memory resources, like Memcache, but transactional and with ability to do search, and something that is also highly available. So on that end, we're also enabled to decouple the database from the application, and therefore we don't have that sticky point that all servers points to and becomes also the bottleneck of the application. So that in itself is also needed to when you want to deploy application on the cloud. Let's see what's other application out there.
Well, one quick thing on databases. One of the things we're very pleased with is we like to think about our data in object form, and we like that with the Gigaspaces we can store the data essentially in their original object form, but we also like that we can have that data persist in an SQL queryable database, and we can use that because we do a lot of data mining as well. We want to understand after we've flown 1,000,000 miles, well, where did we go and what did we do and what are the patterns and what's the pricing and all the things. So we can do offline analysis through an SQL type database and yet keep our data in real time in an object format.
Okay. So we have another last question before I wrap up, which is I think the question is, you have a .NET application accessing SQL Server. Where is the SQL hosted? The basic answer is that when you deploy the application, you don't have to abstract the database if you don't want to. I mean, you could use the self-healing and the SLA deployment and still keep all the application connected to the database as you're used to. If you do choose to front-end the database from scaling perspective, then what will happen is that all the SQL interaction will happen between our in-memory resources and the database itself, not directly from the application to the database. There is a mapping layer which does the OR mapping, the mapping between the in-memory data model into the database. In the case of .NET, we're using n-net, and basically what it will do is call the SQL operation as a background operation that happens, again, between the memory cloud and the database itself, and the user itself is still talking and writing objects and not really exposed to the SQL. We do provide SQL interface that enables you also to interact with the object model in memory via SQL as well. I think that's kind of is the last question for this event. I'd like to thank you all. And Sarah, you want to add that? If there are more questions?
Well,
yes. Thank you very much for attending our webinar. Mike, did you have any last minute?
No, this is Mike again with Amazon. I was just going to add my thanks to everybody for participating. If anyone has any follow-up questions on the settings, we didn't have contact info here on the last slide. But if you would like to visit the respective websites, I think that there's contact us info. Nadi, do you folks have any particular method of contact that you prefer?
Yeah, basically you could contact cloud@gigaspaces.com. I think it's very easy to know. Also, I'd like to encourage you to try out the free demo. We do provide free Amazon access. You don't even need to have an Amazon user to play with the system and try your own trial. We'll actually be running on our own Amazon account. Again, we give it as a free trial, and you can freely access it and use it and play with most of the things that you've seen during this demonstration yourself.
Okay, and if folks have Amazon-specific questions, especially on the technical side, my email is mculver, M-C-U-L-V, like Victor, E-R, @amazon.com, and I'll be happy to help you as best I can. Just a heads up that I will be pretty much off email the rest of the week, so please don't be surprised if I'm a little slow replying. And I guess with that, thanks again.
Well, let me just say this is Jim Harriet also at FlyMeWalk, and we're very, very open and interested in talking to our colleagues in this space. So I'm CTO of FlyMeWalk, and my email is jim@flymewalk.com. So come and visit our website as well as send me email. And we are, once again, pleased to be part of this group, to be doing this kind of work.
Okay, thanks, everybody.
Thank you.
Thank you all. Thank you, Sarah.
Thank you.
Thank you.
Thank you.